Hi, everybody. It's Professor Mitchell. Continuing with Chapter 2, today we're looking at Section 2.4, Introduction to Problem Solving. In this section, we will solve problems involving direct translation, solve problems involving relationships among unknown quantities, and finally, solve problems involving consecutive integers. In this section, we're working on SLO-D, which is to solve application problems using linear methods. All right, so in this section, we will be doing word problems, which I realize are not everybody's favorite thing, but I do have some tricks up my sleeve to help you get through them, starting with what I like to call Mitchell's commandments. So Mitchell's first commandment says, "Thou shalt clearly define a variable." And Mitchell's second commandment says, "Thou shalt write thy answer as a complete sentence." And I'd like to talk a little bit right now about the reason for this second commandment. It's a good idea to write the answer to a word problem in a complete sentence for a few different reasons. Number one, if the problem is in words, the answer should be in words. But also, when you write your answer as a complete sentence, it can help you weed out unreasonable answers. All right. So here is something fun that I saw on Facebook many years ago. This is kind of making fun of word problems and maybe talking about how people have trouble with them. So it says, if you have 4 pencils and 7 apples, how many pancakes will fit on the roof? And the answer is supposed to be purple because aliens don't wear hats. All right. So this is what a lot of people see when they read a word problem. And the reason I'm using it here is I'm trying to make the point that even if the problem makes no sense to you, you can at least do these 2 things, and maybe that will trigger you to do something else. So in this case, the question is, how many pancakes will fit on the roof? So you could start by saying, let X equal the number of pancakes that will fit on the roof. And then before you do anything else, at the bottom of the paper, start your complete sentence where you're going to write the answer. The number of pancakes that will fit on the roof is blank. And so, as I said, writing a complete sentence can help you weed out an unreasonable answer. All right. For example, the answer to many math problems is the number -10. But if you try to put that in your complete sentence, there are -10 pancakes. Hopefully you'll realize that doesn't make sense and you'll go back and find your mistake. All right, so we'll start with problems involving direct translation, or as I affectionately call them, who cares problems. All right. A lot of times when I read a word problem, I'm motivated to do it just because I'm curious what the answer is. This kind of problem is not one of those. I could not care less what the answer to either of those problems is, but they're still good practice. And just for fun, I stuck this in here. Only in math problems can you buy 60 cantaloupes and no one asks what's wrong with you. So it is true that a lot of word problems are kind of lazily written, so the answer doesn't make a whole lot of sense. Hopefully that wouldn't happen with a real life problem, but it does happen sometimes. So I'm going to go ahead and share my screen. And we will start with this problem here. So it says 3 times the difference of a number and 5 is the same as twice the number decreased by 3. So I'm going to start by saying let X equal the number. And then I'm going to skip to the next page at the very bottom, and I'm going to write the number is blank. So this will give me plenty of room to do the problem, check my answer, and feel really good about my answer. Okay, so now for the hard part. The hard part for most people in doing a word problem is setting up the equation. For this kind of problem, it's usually not too hard, so we just take it apart word by word. Starting with 3 times the difference of a number and 5. All right, so we have 3 times the difference of a number and 5. And let's stop there because you know that is the same as is going to be our equal sign. All right, so we'll figure out what does the left side of the equation look like. Well, we start with 3 times the difference of a number and 5. So the difference of a number and 5 looks like this, right? And if I do 3 times the difference, hopefully you realize that that means I need to put parentheses around x minus 5 and put the 3 like this. So in case you're wondering, why is it not 3x minus 5? It's because that would not be 3 times the difference of a number and 5. That would be the difference of 3 times a number and 5. Okay. All right, so let's get rid of that. And now we go is the same as twice the number decreased by 3. So this time it's not going to get the parentheses because it's twice the number and then decreased by 3. So that's our equation. It's a pretty simple equation. So remember our strategy for solving linear equations. Step 1 is to get rid of fractions if there are fractions, and there are no fractions. Step 2 is to get rid of parentheses, and there is one set of parentheses. So let's rewrite this as 3x minus 15. And we'll leave this as 2x minus 3. Step 3 is to combine like terms on the left side and combine like terms on the right side. There is nothing to do there. The left side and the right side are both in simplest form. So now we're going to use our addition property of equality to get x's with x's and get numbers with numbers. So why don't we go minus 2x on both sides? And that's going to give us x minus 15 equals negative 3. And since I put the x's on the left side, that means I have to put the numbers on the right side. So I'm going to go plus 15 on both sides. And that is going to give me x equals 12. All right, so I think this number is 12. How do we check that? Well, in a word problem, the best thing to do is not to check it in this equation, because who made up that equation? We did. So if we set up the equation incorrectly, checking the solution in the equation is not going to do us any good. So we want to make sure that we set up the equation correctly. So what we really want to do is check this solution in the original words of the problem and make sure that it does what it's supposed to do. So 3 times the difference of 12 and 5. So let's, I kind of want to keep it on this screen, so I'm still looking at the problem. 12 minus 5 is 7. 3 times 7 is 21. So the left side comes out to 21. Twice the number, 2 times 12 is 24. 24 minus 3 is 21. Woohoo! All right, so those two sides do come out the same. It looks like this is the correct solution, so I will go ahead and fill in the blank. Oops, okay, got stuck there for a second. The number is 12. All right, next direct translation example. So I have 2 examples of each type of problem. So what I'm going to encourage you to do when we get to the second one is to pause the video and try it yourself. And then once you've tried it, come back and compare notes with me. Okay, so I'll give you a second to pause the video. All right, so hopefully you have paused the video and tried this problem. So maybe I'll do this one a little faster. Again, let x equal the number. And when I was getting my tablet ready, I forgot to leave a blank screen after this one. So I'm going to have to put the number is down at the bottom of this page. Okay, so the difference of a number and 4 is doubled. The difference of a number and 4 is doubled, which means times 2. The result is 1/4 less than the number. So less than is another one of those phrases that you have to be careful with. Forget about 1/4 and a mystery number. Think about, I don't know, 5 and 11. If I say to you, the result is 5 less than 11, does that mean 5 minus 11, or does it mean 11 minus 5? It means 11 minus 5, right? So less than is a phrase like subtract from, where it messes with the order. So that's going to go x minus 1/4. All right, now we go through our steps for solving a linear equation. So I'm going to do something I've never done before, and you don't technically have to do this, but it's often a good idea. This equation has a fraction in it. So what I'm going to do is multiply both sides of the equation by 4. And you have to be careful when you do the left side. I'm going to write that like that. Okay, so let's talk about the right side first. 4 times x is 4x. 4 times 1/4 is 1, isn't it? 1/4 times 4, stick a 1 under there. Goodbye, goodbye. That equals 1. Okay. Now, on the left side, there is a certain mistake that students often make in this situation. We have 4 times 2 times x minus 4. That 4 does not get distributed. We're just going to multiply 4 times 2, which is 8. And then the 8 is going to get distributed over x minus 4. Okay. So distributing the 8, we get 8x minus 32 equals 4x minus 1. So now I'm going to put the x's with the x's, subtract 4x on both sides, which gives me 4x minus 32 equals -1. And then add 32 to both sides. I've got just enough room to finish this. That gives me 4x equals 31. Divide both sides by 4, and I get that x is 31/4. Now you may be wondering, what form should I write that answer in? Should I leave it as 31/4? Should I change it to a mixed number? Should I change it to a decimal? Well, if you're asking me, the answer is I don't care. All right. As long as it's correct. When you're doing your online homework will care, because it's a computer, so it's been programmed to look for a particular kind of answer. Just make sure you read the directions. It will tell you whether it wants a fraction or a decimal or a mixed number. Okay, so I'm just going to leave it as a fraction, 31/4. That's fine. If this was an actual interesting word problem that was counting or measuring something, I would probably not leave it as 31/4. I would probably change it to a mixed number. Okay. All right, so let's look at what's next. Going back to the presentation for just a few seconds. Okay. A 46-foot piece of rope is cut into 3 pieces so that the second piece is 3 times as long as the first piece, and the third piece is 2 feet more than 7 times the length of the first piece. All right, starting to sound like aliens putting pancakes on the roof. All right, but we will make sense of that. And then this one is kind of similar. We'll read it maybe from the tablet. Okay, this is the person your algebra problems warned you about. Look at that. They've got the back of the car loaded up with watermelons this time. All right. I enjoy finding these. Okay, so let's go back to the tablet. All right, I won't read this problem again. I will just skip right to Mitchell's first commandment. And usually when I'm trying to figure out how to define my variable, I go to what is being asked for in the problem. And what the problem is asking for is to find the lengths of the pieces. And I'm emphasizing pieces because what you don't want to do is say, let X equal the lengths of the pieces. You see the problem with that? X is only allowed to stand for one thing, okay? And these pieces are not all the same length. I can tell that by reading the rest of the problem. So X can only stand for the length of one of the pieces. And I am going to say that the best thing to do would be to let X stand for the length of the first piece. And I'm going to tell you why I'm going with the first piece. When you read the rest of the problem, it says the second piece is 3 times as long as the first piece. The third piece is 2 feet more than 7 times the first piece. So the other 2 pieces are being compared to the first piece. So it should be pretty easy to write the lengths of the second and third pieces in terms of X. So what I'm going to say now is then the length of the second piece is, let's read that again, 3 times as long as the first piece. Okay, so if the first piece is X, the second piece would be 3X, right? And the length of the third piece is 2 feet more than 7 times the length of the first piece. So 2 more than 7 times X is 7X plus 2. All right. So here's the piece of rope. I can draw a pretty good piece of rope. First piece is X feet long. Second piece is 3X feet long. By the way, this picture is not to scale. Third piece is 7X plus 2. And the whole entire rope is how long? 46 feet. So do you see how to write the equation? The equation is going to say X plus 3X plus 7X plus 2 equals 46. All right. So first of all, I don't even need those parentheses. I just put them in there because that represents the length of one piece. But we don't really need them to solve the equation. Now I will combine my like terms. On the left-hand side, I have an X and a 3X, which makes 4X. And then 7X makes a total of 11X. And now I'll subtract 2 on both sides. And finally, divide both sides by 11. Okay, so we are due for a check. I checked the first problem, not the second problem. So now I'll check this problem. Let's go back to the original wording. Remember, this stands for only the first piece. Okay, so second piece is 3 times as long as the first piece. That would be 12, right? 3 times 4. And the third piece would be 2 more than 7 times 4. 7 times 4 is 28. 2 more than 28 is 30. Remember, the first piece was 4. 4 plus 12 plus 30 does come out to 46. Woohoo! All right, so for writing my complete sentence, we need to make sure that we answer the question that was asked, which was find the lengths of the pieces. So we need to talk about all the pieces. The pieces are 4 feet, 12 feet, and 30 feet. All right, next example of solving a problem involving unknown relationships among unknown quantities. We have this one here, and I'm going to again ask you to pause the video and try this one. A 21-foot beam is to be cut into 3 pieces so that the second and third piece are each 3 times the length of the first piece. If X represents the length of the shortest piece, find the lengths of all 3 pieces. So please pause the video and try this one. All right, hopefully you've tried it. They kind of did Mitchell's first commandment for me, but not a bad idea to write it again anyway. Whenever I have the opportunity to look at your written work, I will automatically give you some partial credit if you do Mitchell's first and second commandments and you don't do anything else, right? It won't be a whole lot of partial credit, but it'll be something. Definitely better than leaving it blank. Okay, so the length of the shortest piece, and maybe this time instead of writing out the whole thing in words like I did the last time, I'm just going to draw a picture. That should say shortest piece. Okay, so here is my beam. Beam is a little harder to draw than a piece of string, but I think I can still handle it. It's cut into 3 pieces. You've got the first piece, and then the second and third pieces are each 3 times the length of the first piece. So these 2 pieces are both 3x. And the whole beam is 21 feet long. So our equation is going to be x plus 3x plus 3x equals 21. Those 3 terms combine into 7x equals 21. Divide both sides by 7. We get x equals 3, which is the shortest piece. So if the shortest piece is 3 feet, that means the other 2 pieces are each 9 feet. And I can see that 3 plus 9 plus 9 is 21. So that answer makes sense. The pieces are 3 feet, 9 feet, and 9 feet. All right. Back to the presentation. To look at the last type of problem we will solve in this section. Okay, let's see. Oh, how did that happen? I swear I changed these letters to be C and D. I don't know why it didn't come through. And I also changed these to be E and F. I remember very clearly doing that when I was in my office earlier. And for some reason, it didn't come through. Maybe I forgot to hit save. Okay, for the 2010 Winter Olympics, the total number of medals won by athletes from each of the countries of South Korea, Russia, and Austria are 3 consecutive integers whose sum is 45. Find the number of medals for each country. And then we have this other problem. A quadrilateral is a polygon with 4 sides. The sum of the measures of the 4 angles in a quadrilateral is 360 degrees. If the measures of the angles of a certain quadrilateral are consecutive odd integers, find the measures. And here is the last funny that I found. 2 Math for Dummies books at $16.99 each. That'll be $50. So we don't want to let that happen to any of us. That's why we're here. All right. Okay. Back to the tablet. Okay, starting with the Olympics problem. So we did a problem involving consecutive even integers. I can't remember exactly when that was, a section or 2 ago. And so there's a certain trick that we used in that problem. Let's see if we use the same trick in this problem. So notice it says consecutive integers. It does not say consecutive even integers this time. So what's an example of a set of 3 consecutive integers? That would be like 8, 9, and 10. Or 62, 63, 64. Okay, so if you remember the trick that we used when it was consecutive even integers, to get from one integer to the next one, we added 2. This time we're only going to add 1. So if the first integer is x, then the second one would be x plus 1. And the third integer, to get from the first to the third, you would add 2. So the third one would be x plus 2. And it's saying that these 3 countries won a total of 45 medals. I did not define my variable yet. Let me go ahead and do that. Now, oops, typo. I have discovered it is harder to type on an iPad than it is to type on a keyboard. At least it is for me. Okay, because they wrote the countries in the order South Korea, Russia, and Austria, I'm going to assume that South Korea won the fewest and Austria won the most. At least that's how they should have written it. So we're using X to stand for the number of medals won by South Korea. Okay, and our equation is x plus 1 plus x plus 2. Those 3 numbers should add up to 45. Again, I don't need the parentheses. Combining like terms, I get x plus x is 3x. 1 plus 2 is 3. So we have 3x plus 3 equals 45. Subtracting 3 from both sides, we get 3x equals 42. Dividing both sides by 3, we get x equals 14. So this is saying that the first of the 3 consecutive integers is 14, which means that all 3 integers should be 14, 15, 16. And those do add up to 45. So we're ready to write our answer. The question was, find the number of medals for each country. So I would say something like the number of medals won by South Korea, Russia, and Austria were 14, 15, and 16. Here's something you may or may not know. When you write three answers in sequence like that, and you want the 14 to go with South Korea, the 15 to go with Russia, 16 to go with Austria, you should use the word respectively. That means the two lists are kept in the same order. So I try to sometimes teach you a little random fact, even if it isn't about math. All right, last example. Again, I would like you to try this one. Okay, so we read it earlier. I'm not going to read it again. Go ahead and pause the video and try this one, and then come back when you're ready to compare notes. All right. So the biggest difference in this problem is that the numbers that we're looking for are consecutive odd integers. We have now done a consecutive even integer problem, and we just did a consecutive integer problem. Now we're doing a consecutive odd integer problem. So hopefully you figured out that pattern. Let's say let x equal the measure of the smallest angle Okay, so what would be an example of a set of 4 consecutive odd integers? Well, it would be something like 13, 15, 17, 19. Or 55, 57, 59, 61, right? So if the first one is X, and I enjoy this situation in particular because whenever I ask students without, doing this, really getting in there and looking at the pattern, and I ask, okay, if I call the first one X, what would the second one be? I'll hear X plus 1, X plus 3. They always want to put an odd number there, which I get. But if you notice, to get from one integer to the next, because they're both odd, they still differ by 2, just like if it was a consecutive even integer problem. So these are actually set up the same exact way as consecutive even integer problems. To get from the first one to the third one is plus 4, and to get from the first one to the last one is plus 6, right? So we want those 4 numbers to add up to 360. This time I'll write it without the parentheses. Combining like terms, I have 4 x's and 2 plus 4 plus 6 is 12. A couple sections ago, we did a problem involving 4 consecutive even integers. And that problem was just to find the sum of the integers in terms of x. And this is exactly what it came out to. It was the same answer, 4x plus 12. All right, so we have 4x plus 12 equals 360. I'm going to subtract 12 on both sides. Gives me 4x equals 348. Divide by 4. This is where you may want to have your calculator handy. 348 divided by 4 is 87. So the measure of the smallest angle is 87 degrees. That means that all 4 angles are 87 degrees, 89 degrees, 91 degrees, and 93 degrees. This thing would almost look like a rectangle or a square. Not quite. All right, and that's going to do it for section 2.4. we will see you next time.